WeeklyWed. WeeklyWed is our speaker series that happens every Wednesday at 9 a.m. Pacific time. And I'm your host, Yashaswini Vishwanath, and you can call me Yash. I'm logging in from Bangalore, India, and please type away where you're coming from, and we would like to get to know you better. So, WeeklyWed is an international speaker series, and we have speakers from all over the world who come to us and give us key learnings. Today is a very important day, and I would like to give a very small introduction to get this started. We know that smart energy uses enterprise communications to communicate between smart grids and smart buildings. Don't worry if you didn't get any of these things. Here today, we have a very special speaker with us. We have Toby Considine, who's going to talk to us about a lot of things, but I would like to first introduce Toby and give a brief introduction. So Toby is the member of teams that developed the National Smart Grid Roadmap, which are expediting the development. And Toby has been contributing to a lot of energy related stuff. Like he's the signer of Gridwise Architectural Council Constitution, participate in the NBIMS committee. Toby has been the frequent speaker at conferences on interfaces between IT and capital assets. I'm so happy that Toby Considine made time for us today and has come here to share key learnings with us students so that we will make a difference in the AI space. So Toby comes with great experience from transactional IoT, and here is Toby with us. Thank you, Toby, for taking time out, for coming here, and we're all ears to what you have to tell us.
Thank you for that kind introduction. Let me spend a minute and try to share my screen and get up to a slide deck. There we go. So, this was put together quickly from some old decks. There was a U.S. president once famously apologized for writing an 8-page letter, but that was because he didn't have time to write a 2-page letter. And I hope that this presentation doesn't suffer in that way from having been done quickly. When I'm here talking about smart energy and what they're called the common transactive services, which I'll explain what those are in just a bit and why transactions matter in the Internet of Things and in energy. I have a lot of hats. Today I'm speaking as the director of the Energy Mashup Lab. And so what is smart energy? Well, there's a lot of definitions. The one which might resonate with some of the California people logging in that I've seen is that the grid of the future is going to be horrible. And that's the plan. I said that all over the country when I was doing the smart energy roadmap for NIST and Department of Energy. And people would wince, but they never disagreed with me. The purpose of smart energy is to make it that those at the end nodes, houses, buildings, factories, don't care about the poor quality of the grid. And that's the challenge. We can see since then, all this information has gotten much more readily available. We have whole towns that are turned off for weeks at a time in California. We had the failures in Germany last winter and Texas in last winter and last spring. We're seeing the problems in Britain in the last month. All of these things, all this unreliability, instability is only going to get greater, and that's the plan. So smart energy is how we deal with it. And so the question is, how do we deal with it? And what can we do? There's two models. One is the model that says, if we just have enough data centers with enough central control, enough knowledge of everybody's visions, they can solve all the complexity that we can imagine. I think that's doomed to failure, and I think it'll fail badly. Transactive architectures are instead another approach that comes out and tries to deal with them with edge-based decisions and edge-based thinking. So the standard, which I'm going to talk about, is in OASIS. OASIS is a global nonprofit consortium. It's a direct submitter to ISO and IEC. There are many times in areas such as energy where you cannot use a standard unless it's accepted by is promulgated by one of a few groups. OASIS is one of such groups internationally. You use OASIS standards every day. You just don't even know it for the most part. So I have been integrating building controls and campus power distribution systems and steam distribution systems, just about every kind of control system you can think of for a long time. That led to being the problems of integrating between these control systems that didn't speak to each other, led to me becoming head of OBIX, which is my first real standards effort, which is now used all around the world as sort of a middleware between control systems and the enterprise. I wrote the US National Smart Grid Roadmap. I'm now working on the OpenC2 language, which is service-oriented cybersecurity, which is an NSA initiative to try to get vendor-agnostic cybersecurity deep into infrastructure, particularly in because infrastructure is poorly secured. I'm director of the Energy Mashup Lab, which promulgates free open source software for transactive microgrids. And I work with a number of startups in the spaces ranging from microgrids to digital twins. The challenge of smart energy is we're implementing a number of transactive energy systems and integrating growing amounts of DER, distributed energy resources. Distributed energy resources are often intermittent. They're not controlled. They're not like old-fashioned power plants that are just turned on and running flat out all the time. They also are at a much lower operating margin. Up until 1973, the US power grid ran at between 30 and 35% operating margin. What that means is however much energy was needed, there was a third more, or actually 50% more, because the way thirds work, at any given time. So if you and your neighbor across the street and somebody else all turned on your air conditioners at the same time, it was just in the noise. Nobody noticed, nobody cared. It didn't destroy power quality. Today we're working routinely at under 10% operating margin. And well, I know in my house, in warm spring and summer days, I cannot run my dishwasher with the electronic controls if after about 9 in the morning, because the air conditioners going down are going to cause enough power quality problems that the digital electronics in my house is confused. So this kind of problem is becoming more and more prevalent, whether or not there's things dramatic such as turning off towns. And so how do we deal with it? How do we make things that interoperate at scale? And at scale, this means continents at a time, or perhaps the whole world. That's a big scale. First, I'd like to define a term, which is transactive resource management. Transactive resource management is one of my favorite concepts for integration, because it relies on emergent order rather than central control for things. I think it's the last and the greatest gift from the Palo Alto Research Center to the world. Palo Alto Research Center is famous for giving us the mouse, the window interface, the stuff that came to be Ethernet, laser printers. A number of things came out of that think tank. But in the early 90s, they were dissatisfied with the comfort they were getting from the single furnace that they had in the basement. Bernardo Huberman and others set up a market where the various heating grills throughout the building would bid for the output of the furnace over time. And so a particular room that was feeling particularly cold or uncomfortable would bid higher. And they used this to allocate the heat coming from that one furnace. Comfort levels went up. Overall budget for heating the building went down. It was a great success. And I've got all the links down below on the bottom of the screen for anybody who wants to review that stuff. But It's a well-known and well-understood capability. Later on, Ed Cazalet, who had at one time was the CEO of California ISO, pioneered consumer markets for electricity, and he came up with the term transactive energy. So, and that was in the early 2000s. So this has been out here for 20 years, but it's little understood and little thought of, largely because of interoperability and lack of standards. So maybe my utility does offer me transactive energy, but I can't buy software from across state lines that knows how to talk to it, because everybody's different, everybody does it different ways. So in the National Smart Grid process, well, let me go back. I have a tendency to fall into inside politics on standards, and that's boring for everyone. So let's just define some terms. A resource is a commodity whose value to an individual is determined by the time of day it is delivered. So power is like that. Power at 2 a.m. is an entirely different product than power at 2 p.m. It's just got different value, and that value is determined by what other people want to do with power. So what transactive resource management is you create markets that are in time, basically bidding for time slots of delivery, and you clear it over time. And to think about it, it's always easiest to think about it in a house, because we all think we know how our houses work. You might have a limited budget coming from your solar panel. Let's leave out the grid and anything else, like any other complexity like that right now. And what you want is, you don't want your dishwasher, your refrigerator, and your air conditioner to run at the same time, because then you'll blow out your inverter and you'll be offline for 6 weeks, and that'll make you unhappy. But you don't want to have to teach your dishwasher about the air conditioner. You don't want to have to teach your air conditioner about the refrigerator. You want these all to be agnostic at each other. Well, if the air conditioner is running and it's made a power buy against the local power market for the next internal house to the house power market for the next 7 minutes, the refrigerator can look at that and say, you know, I don't mind holding off a cooling cycle for a few minutes. It's not going to hurt the services that I provide, and I can get my power more cheaply. So then, instead of having things stacking on top of each other, they smooth out spontaneously to get smooth power use over time. Now, if the power supply is volatile, that's a minor difference. It still can align supply and demand. We know how this works. I know in America we can walk into any grocery store and get blueberries any day of the year. Now, they'll be more expensive sometimes than others, but if I really want them, I can get them. And if I only kind of want them, I'll look and say, whoo, that's too much. We know about prices over time. This just applies this to daily cycles of life, such as energy, such as water. I've seen it used for natural gas pipeline allocation in Europe. I've seen it used in data centers to schedule large block transfers between servers. Thermal delivery, of course, is where we started on this. I've seen it used in transactive agriculture. So these are these growing principles that are starting out there that are beginning to be well understood. What? Uh-oh. Just a minute. Somehow, when I brought up that PowerPoint, I grabbed a snippet from something that was recorded from elsewhere, and it, how do I do this? So all of a sudden we got the, okay. Sorry, that's what happens by watching through these, and I'm going to be on the non-screen view shot for a few slides, because otherwise you have to watch me. Okay, how do I do this? Okay.
Okay, take your time. This is really fascinating. You're gonna give us a couple lines on what TE specifically is.
Yes, I will in just a minute. And I welcome people stopping and saying that stuff to me as they go. Unfortunately, a couple of these slides had embedded video, recording video that I failed to check for. That's because of the overnight nature of this particular presentation. So I'm going to go out of screen presentation mode. I'm sorry that gives you less screen real estate for a moment, but it means that I won't be talking behind me. Why does it say it stopped? Am I sharing my screen or not? I'm getting ambiguous.
Yeah,
Yes, yes. You're
Okay.
sharing the screen.
Great. So TE is transactive energy. TE says that you get different prices at times of day and different people might be bidding into the market. So it's a form of, it's transactive resource management applied to electricity. Now, today we think that prices in electricity all come from someplace far away and they set them up at the Utilities Commission and it's a long way away from us. And I think that's the wrong way to think about it. Think about it, transactive energy is a way to allocate energy within your home, within your zombie escape fort, whatever reason you think you need to escape for the zombies for. And then you've balanced electricity and now you want to share electricity with the neighbors in ways that improve your resilience, but you only want to do it after taking care of yourself first. But you can improve their resilience and they can improve yours. So that's a different way than the utilities think about it. But if a utility gives you day ahead pricing, it's essentially transactive energy then too, because if you have hourly pricing for tomorrow, as you get in some California territories, for example, that's essentially a set of tenders for tomorrow that you can commit to in advance. A key component of properly managed transactive energy is that every tender is a committed purchase. I mean, every contract is a committed purchase. What that means is if I buy power for an hour tomorrow and then go to the beach, I've already bought that power. The upside of that is that means that I have an incentive to try to get rid of that power by selling it to my neighbors, which means rather than having a single vendor market, which never works well, you have a market that has as many participants as there are in the market as potential vendors as well. That allows honest market dynamics to exist rather than all of us just being price takers from the sky. So that's a critical economic distinction. Does that answer your question, Henry?
it does. I immediately think of PG&E when you talk about a single vendor market. PG&E is not going to give up what they've got. And so we can't, it's very hard. Am I thinking right here what you're talking about?
Yes. So PG&E is willing to have day-ahead markets. The project I worked on for NIST that I'll describe later was actually modeling transactive energy in PG&E markets using, it used prices from PJM, which is the Pennsylvania, New Jersey, Maryland ISO, but it also related to PG&E day-ahead markets. So established common knowledge between them. And it's being used by NIST to model future transactive energy markets. We'll get to that more presently. But let's talk more. We'll get to it. And I'll ask the questions at the end, because otherwise I'll end up doing all my slides twice to answer that question out of sync. Is that fair? Okay. So I don't know when I'm going to get through the, let me at least get rid of that so it's a little bit better for you. So some of the things that you want with TE is rapid integration. If all you need to know, I mean, you go to a farmer's market, what does it take for you to get integrated? Do you have a wallet? You're integrated. It's a very simple plug and play integration. You don't have to register your water heater. You don't have to say what brand of dishwasher you have. You don't want all that. Are you buying or selling? It's the only place. So it's the lowest, it's the easiest, lightest integration. That means it supports what we call virtuous markets. Virtuous markets are consumer-driven and value-driven. Utilities-driven markets are inherently cost-driven. Some of us, I suspect Henry might be old enough, can remember black phones that you could not get upgraded or replaced until the phone company had depreciated them for the 14 years that they had on their books. Even if you broke them or chipped them, you had to keep them. So that's a cost-driven market. And that's the way the entire grid is managed, is a cost-driven market, because every cost has to be defended to the Utilities Commission. Our phones have changed into a value-driven market. You get a new phone because you like the screen, or you like the battery life, or you like it has a new app, or you like its color, something that makes it make sense to you. And so we've watched as phones switched from cost-driven markets to value-driven markets. We've watched rapid evolution of technology and features and functions. Anything to do with energy today is driven by the, I have to sell it to PG&E since you named them, but it could be anybody else. They are not uniquely bad at this or different. It's just the rules that they're playing with. You know, why did you hit me? We're playing football. Of course I hit you. So they're cost-driven. And one of their biggest risks is they're going to get someone in a truck. He's going to drive an hour and a half to your house, look up on the pole and say, I've never seen one of those. And so one of their biggest risks that they cannot control is the risk of diversity of technology. So they want to make very few choices and maintain them for a very long time, which is exactly what the rules that we have them operate by drives. Transactive energy means that the consumer technology choices are driven by the consumer, which means you can have markets. Some people can make good decisions, some people make bad, but you have constant evolutions. That's something you want in a virtuous market. So that's the change we have to go through. And transactive energy is being considered very strongly by the California Energy Commission, since you're mentioning PG&E again, and they're struggling to figure out what the rules are. The other aspects is, if you're knowing everything in my house, then I have no privacy. If I can tell when you go to bed, if I can tell when you have visitors, if I can tell when you cook, if I can tell when you use exercise equipment, you have no privacy. And I've been in meetings with smart grid people, with most utilities in the room, where they're looking at, say, selling information about when you do things in your house to insurance companies to adjust the rates you get. And I don't mean home insurance, but health insurance. And I'm not saying they all do that, but that was a serious meeting issue, and that raises the privacy flag pretty high and pretty heavy. And we all know that once privacy goes to the cloud on any subject, you don't get it back. You can change vendor, but you don't get your data back. So that's important. And also, you don't know what I would do to turn off power if you asked me to. If you decide, this violates another economic precept of the knowledge problem, which is that the central planners don't know what each of us values, so they can't know how to optimize our happiness. They just don't know. We know. Each of us knows. So we want autonomy on the edge to make decisions to cooperate on this stuff. There have been many TE trials. Everyone uses proprietary messages and APIs. Researchers and regulators are having agreed on the best market design, whatever that means. People are having fights about how to manage their data. But because every trial starts from scratch, there's no built-in functionality, there's no marketable products, you can't buy something that will interoperate tomorrow. So, meeting with NIST about 4 or 5 years ago, actually starting in 2015 and at the Transactive Energy Conference in Portland, we decided we needed to come up with a simple standard that met modern programming, modern IoT techniques, an actor model that would allow all the different markets, all the different equipment, all the different approaches to interoperate. And we started calling that the Common Transactive Services. So this conversation was started because the Common Transactive Services is out for public review right now. And I told the IoT Council this, and we started having a conversation. They said, well, why don't you speak to us tomorrow? So that's how that happened. NIST is here using some of the same language I just used. They want virtuous markets. We want a path toward interoperability without having to decide how everything is going to finally work eventually. We want a layered approach that works with all the different players at different levels of the grid. We need simple, extensible, and open source standards. So a common transactive services draft is open for public review. I am the editor of that specification. I would love to have comments. The comment process is pretty easy and simple. Let's go to OASIS, sign up. There's a listserv you have to register. You know how many listservs you sign on to. You get a message guaranteeing that, checking it's the right email address before you actually are enrolled. They have the IP licenses on that reply, so that anything that you contribute to an OASIS standard, you can't come back later and say, oh, you owe us a penny for every electron. So the IP shrink wrap is essentially in subscribing to the listserv, and then you can put all the comments you want in. So it's we welcome that. It's a very open process. It's lightweight. If I don't have a link later in this document, which I think I do, then I'll share them later with this group. So the purpose of CTS is to get common semantics and interaction patterns for markets. It doesn't define exactly how systems will be provisioned, which is you have to sign up. Does your electrical company have to enroll your house? Can you enroll your house automatically? Those things are out of scope. But it wants to have every microgrid model that there is out there able to interoperate cleanly and easily by having a common information model and message model. Now, different providers might have different encryption technologies. They might have different security and sign-in authorities. Those are fine, but those are easy to solve if you have common message models at the heart. And this is right from this description of this project, this stuff. So the common interactive services have just a few things. You can have a quote, which is what we'd call a non-actionable information about a price. You don't know you can buy it at that price, but there's a price indication out there. There's a tender where someone actually says, I'd be willing to buy it at this price. I'd be willing to sell it at this price. If you've ever been on a stock portfolio page or something, you see this basic information such as, this is the last price in the market, this is the high and the low today, what's your tender? What offer are you putting in the market? And sometime later you may get exactly that price or something that is close enough to that price based upon the market rules. So that's what a tender is. A transaction, that's when you actually get a committed purchase of price. You may put a tender and get 3 different transactions at different prices, different people that match. Tenders can be to buy or sell. So this is the basic building blocks of building markets. There's a delivery. Somewhere you have to find out what you actually got and took, because I may have bought this, but I may have taken delivery of some other amount, and that has to be reconciled. And there's a notion of a ticker, like a ticker tape. What else is going on in the market? What else is going on in the market is a place where AI might have a very interesting play, because what are the patterns? What should my bidding strategy be built around? Should I put on a really aggressively low prices for what I want to buy, but how long before I actually need it? Do I have to switch to higher prices? How is the market flow going to work? All kinds of that are outside and beyond the spec, but if you're seeing the actual transactions and learning, you might come out with a great trading algorithm. So the energy mashup, as part of working with NIST on this, actually came up with an open source system. Version 1 was used just for actually modeling transactive energy systems inside NIST's big modeling framework. Everything that comes to the lab is Apache 2 licensed, open source. We're tending towards the actor model. You can see that each node is participating with a particular market. That communications bus is also where a market exists. You can stack them, you can arrange them, and there's no particular privileged locations anywhere on it. We're going to go through a little bit of that architecture from another view, less abstract, in just a minute. But so here we go. Here is what we implemented for NIST when we came out with this open source pattern. You have a bunch of what we call transactive energy user agents. Those represent you and bid into the markets and buy for you. There's stuff inside the market that, if they get valid messages, actually comes up and decides, does this match that as a valid request? All that other stuff, that's isolated. If you're in a 1 hour market, you can't buy 17 minutes of power. That'd be an invalid message. If it's a 10 megawatt market or 10 kilowatt market, you can't buy 3 kilowatts. That would be a invalid tender. So that gets filtered out. If you try to get too much diversity in that, then you get a market that's illiquid. Nobody is ever going to bid for a 17-minute market for your one tender. You'll just never find someone to sell what you want to buy. So you might have to do 3 5-minute purchases and 2 1-minute purchases, depending upon the market rules. So that's all incorporated in the local market agent into the messages. So again, this is the open source you could download today and start playing. By the way, this is available as Dockers. So you can put it on your Mac desktop, you can put it on your Windows desktop, you can put it on your Linux desktop. You can deploy it in large numbers to whatever your favorite cloud is. All that stuff is going on. These are a series of open source projects that have been done as the senior projects for, or last semester projects for seniors in IT at New Jersey Institute of Technology and master's students at IT at New Jersey Institute of Technology. And it's a continuing project, keeping on adding features. This semester's they're working on Dapper support. They're working on SBE, which is a fintech specification for communications. And they're working for multi-product markets.
Give me again, what's the name of the open source? Is it a software? Say again.
Just look for the Energy Mashup Lab on GitHub.
Okay. Energy Mashup
Lab.
Okay.
That's the EML down below on the slide.
Got it.
So, and right now, how you actually encode the messages, we're working on the FIX Zero Trust profile as well. The FIX is the Financial Information Exchange, the group that makes most of the standards for financial markets. And they have a zero trust profile that they use. They have Raspberry Pis that are on the internet directly connected right now, trading in NASDAQ and stock exchange markets. So we're implementing that model in the open source. So that's the kind of thing that you could safely put on the outside of your house on the open internet, if you so desire. So we're trying to incorporate more and more security standards into that. There's kind of an abstract model of what's going on because the market behavior is only part of it. Some of the things are, but what is the building actually doing? What equipment's inside there? What are its needs? Does the weather report say it's going to be cold tonight, so I need to buy more energy for my furnace? All kinds of things that might be going on under the covers. But the market just cares about what you're trying to buy or sell. And this now enables you to be a competitive market in energy managers that take more information or less information that allow you to plan better. And of course, anytime there's a pattern or consistent set of messages or load curves, there's an opportunity for AI to perfect them, to predict them, to do better jobs at that. So I see a model that's slightly different. I'm personally committed right now to what I call fractal microgrids. So fractals have self-similar behavior at each level of the fractal. You can see you can be as deep or shallow as you want. You have these markets that things clear out. I see every microgrid is managed, but power distribution in any microgrid is managed by a micro market. Any node can participate to either buy or sell in that micro market. Every purchase is committed so that if I bought an hour of power because it was cheaper than the 5-minute market, but I only want a half an hour of power, I can then make 5-minute tenders if there's a 5-minute market locally to my neighbors to try to sell off the rest of the half hour that I didn't need. So then you start getting spontaneous smoothing within my house and across neighborhoods and get rid of the volatility that so troubles the current grid. The correct place to sell distributed energy is to your house first and then to your neighborhood, and to not make the grid so complex. So at each level, as you go up from the bottom, from these nodes at the bottom, up to the next node, up to the next node, and perhaps up to the utility, you are swallowing complexity, swallowing volatility, and encapsulating privacy. So this is the only model that I know that actually preserves privacy for smart energy, because you don't have to tell anybody why you're doing it or what you're doing it. You could even stage your purchases to effectively lie to those around you. No, I want them to all think I get up at 3 in the morning, because that's what my energy purchases look like. It's nobody's bother. You can do whatever kind of privacy screen internally that you want, as long as your interactions with the market are proper and correct, and they clear and balance over time. So that's how I think it fits together long term. And I think the early adopters are not going to be in the middle of a city on a big utility. I think they're going to be rural communities. I think they're going to be vacation homes. I think they're going to be lots of people. I think they're going to be military bases. There were some rather choice words from the Marines to the California Energy Commission when the utilities protested that they were unable to monitor the solar panels and batteries on Camp Pendleton. This is back in 2012. And the Marines explained exactly what they thought about listing operational facilities in a public place in data sets they didn't control, much less their current operational status. And you can imagine how that meeting went. So, but we all have the same concerns. We just aren't quite as strong at pushing back as the Marines are. But Marines are now regulated as a peaker, all of Camp Pendleton, meaning they're an entity that may choose to sell power to the grid or may not, based upon current prices and its own internal decisions. And anything that goes on inside is invisible. That's as it should be at each level of the microgrid. So it can be done. It's just taking a while to get through all the regulatory stuff. But I think it'll come disconnected grids first is my guess. But I'm also seeing resilient neighborhoods being built. New construction, greenfield, where every house is being built for this model from day one. There are certain things that they're doing. The last thing that every new neighborhood does traditionally is they deed the roads over to the city. Well, regulations in every state in the US say that if your wires cross a publicly owned thoroughfare, then you're a regulated utility. So now you see new neighborhoods who are not deeding over their streets to the city, so they can run this kind of model across their new developments and escape regulation. So
Toby,
yes.
I just want to jump in and say this. Can we offer transactional the IoT space, whatever you're talking about, like if we can offer EV charge as a transactional market for the neighborhood?
Sure. No reason why not. But you just have to gain control of your own wires.
Okay.
So we have these motions. So San Diego, for example, in California, has announced a plan to break the neighborhood up into 12. I mean, that's the city up into 12,000 microgrids. Well, then any trading with a microgrid is thoroughly allowed. So you have these people that are reaching toward this, and yes, EVs are going to be a great model for that. When is the right time to charge your EV? And there's some complexities. So everybody wants to charge their electric vehicle in 5 minutes, but the faster you charge a lithium battery, the faster you age that lithium battery. Slower charges last longer. You should be making those decisions as an IoT thing, not just thinking solely of speed of charge, either direction, but also life of your asset and what your personal values are. That's the kind of thing that can't be done from central authority and control, but only can be done by the local owner of the electric vehicle, which means the interface for the electrical vehicle or for the electrical vehicle charging station then becomes a competitive point on who explains the values of this owner best and gives them a user interface that does that best. and different people will opt for different ones. And that's okay. One problem that the utilities have is structural. It's not because they're bad guys, it's just structural. They always have to adopt technologies that are ready for the late adopters.
So,
And
Toby,
nobody successfully introduces new technology aiming at the late adopter mindset. IoT people are going for early adopters.
Toby, I was just thinking, is there any,
Can we stop sharing the screen so we can see you guys? Sorry.
Sure, happy to.
Yes.
I don't know if you're going to make this available later. I'd like to come back and say a couple more things. I have 2 more slides that actually have information on, but I can stop sharing now so you can see people.
Okay. No, because Yash was asking a question and it was
Sure, happy
tempting for me to read your screen. Sorry.
Toby, is there a global market for transactional IoT market for energy?
Is there a global market? Well, you can only sell where there's wires. So I can run all the solar power out of my house I want. I can't sell it in India because I'm not connected to India. So global market needs some definition. Is global markets drifting in? I've seen transactive energy projects in central India. I've seen them in Brazil. I've seen them in California. I've seen them in the upper Midwest in the US. I've seen them in military bases. I've seen them in England.
Okay.
So yeah, they're developing. It's not like you can walk into the store and say, I'd like to get a transactive energy device today. You can't.
Okay.
But it's all over.
I got the point that where we can actually apply this. So WeeklyWed is a place where all student alums of Sudha come together. We have students of artificial intelligence, autonomous vehicles, and IoT, and a lot of other subjects like AI ethics that we study and we come here. So I was just thinking when you talked about all these technologies, is there some part of AI that can come in and make a difference?
So I can barely spell AI. So if I say anything that's horrifying, that's why. But as my understanding, AI is based upon getting somewhat simplified abstractions of whatever you're measuring, and then looking for patterns and trends of some kind, and then adjusting behaviors to optimize decisions you make to get better patterns and trends in the futures, crudely. Transactive energy and generally, and the CTS messages themselves are, to the extent that I'm able to do, pre-optimized for being fed into AI systems for consumption. What you do to figure out how do you respond, what is the optimum strategies you come up with, I'll leave that to the AI guys, because it's not me. But they're there. There's also, if I'm going to be buying for my house, if I'm the agent, I'm not Toby in here, I'm the agent sitting by the thermostat or wherever it lives, I have to make some kind of guesses as to what the house is going to do. That's another place where AI could inform my guesses. Maybe the devices aren't that smart, but I know something about them. So if that refrigerator is kept from cooling for half an hour because some other thing is going on in the energy, it's not going to run the same pattern that it does normally. It's going to run for a little bit longer because it got warmer before it ran again. What does that load curve look like? That's a great place for informing the agents. Yes, AI can definitely interact with the transactional AI. Whoever observed that is exactly spot on. I think that's correct. These chats, 20 chats coming by, I haven't read them. I can.
No, Yash will fill those questions for you. She keeps us chatting so that.
Okay, good. Okay,
Yeah.
good, because I'm bad at chewing gum and reading
No,
messages. At
she'll
the same
take
time.
care of it. Yeah.
I'll do that. And there was something that was pressing when you talked about this entire thing. It was about the privacy issues. So there is a central grid which monitors all of this. There are these communication protocols that keep talking to each other. So what about the people's data? How are they made secure?
So what I was about to do is go through some slides to tell just that. I don't think those grids need to go centrally. If you've got a fractal model for integration, you also have a fractal model for markets. You could have some privacy leak to your neighbors. My neighbors always know whether I'm cooking, whether I'm barbecuing or making curry tonight, because they live next to me. They can smell what comes out of my house. You can't have perfect privacy from your immediate neighbors, and that's a fantasy. But if my cul-de-sac is a microgrid, then there's no reason for any of my transactional data to flow out of the cul-de-sac. If my cul-de-sac is one of many microgrids participating up and down the street, there's no reason for the aggregate market positions of all of those nanogrids to flow out of the street microgrid. If the street is one of many streets in the neighborhood, there's no reason for the internal privacy of any of those streets, which are then nanogrids within the neighborhood microgrid, to flow out. So at each level, you blur the personal behavior and the personal details. And so there's less and less information. I mean, direct monitoring of electricity can reveal an awful lot. And that's well known.
I think so. Tell something.
I have a question. So I know you're managing time, so if you don't want me to speak up now, I can wait. But otherwise, we should give.
I don't have a pressing thing next, so it's what your schedule drives it. I can talk for longer.
Yeah, if Yash allows it, we can go for another 10-15 minutes max. Yeah. Okay. So I have this question about the privacy part. So I'm very big on data, can tell you many stories that the users don't intend to share. So,
absolutely.
So if you're monitoring a whole neighborhood just for transactional market to give us energy, say for a street or a cul-de-sac or couple streets, if say for Thanksgiving now, whole streets are going to go dark because people have gone out travel, or there are going to be parties and Thanksgiving dinners, and the street might be lit up. And there are certain streets in our neighborhood, I know where it will be dark, I know where it will be quiet, right? Where there will be people and activity typically, right? So now you have that information by my energy consumption saying everything went dark. That means this neighborhood does not, and you can see a pattern and say this street goes dark during Thanksgiving. And
you said you.
I don't know. I could be
question, which is who the you is. So I agree very much with the precept. The very first time someone analyzed energy usage in a house, they quickly saw the stuff you could see in Google Energy until they took it down because people thought it was too creepy.
Yeah. That's where I'm going. So you can actually
see the air conditioning going on, and that was fine, and then you could see the refrigerator, and that was fine. And this is the first time they did it, and they had cruder tools than now. This was 25 years ago.
Yeah.
And they quickly got down that they knew every energy use signature except for one, which happened sometime 25, 45 minutes after everybody left the house on school days, work days. They finally figured out that was when the dog, knowing they were not
I was wondering if us
would go and get on the waterbed, and it changed the heating pattern of the waterbed. And after they watched it a little bit longer, they realized that they could tell when the dog was restless or not. Somewhere that, no matter what your tolerance for privacy, that eventually goes across into the creepy line. Yeah, absolutely.
No, I'm just thinking if this data, so somebody who's a microgrid provider has this information, if there are many such microgrids, I could become a data intermediary by buying that information, right? If there is a price to pay for information, and I could become an intermediary and say, which are my streets are safe, sell that to the cops to come and monitor our streets during Thanksgiving.
So there's all kinds of
thief
who could might happen.
Yeah.
So one, we all say we like privacy, and two, we all carry surveillance devices around in our pockets all the time. So people have to get to make their own choices. A lot of people don't realize how much surveillance is going on their phone in their pockets, but people get to make their own choices. Now, if I get a cheaper neighborhood microgrid because my microgrid providers is permitted to sell it, that's a
Yeah.
decision maybe I could make. I would prefer not to make that decision that way myself, but they could. It's
Yeah.
a legal thing. But the model, and I was going back to, if I could go back to the slides for just a
Okay.
mere second,
Yeah.
because
Yeah.
I think it addresses some of this stuff.
Yeah, she can do another 10 minutes at least, right?
Yep.
Yes.
Okay. Thank you, Toby.
So I've got the technology model that I'm working on right now is something called Dapper, which is much smaller than Dockers and other traditional containers. And they actually allow you to build whole clouds on Raspberry Pis on the edge. So my model, my actual current work, which is in a stealth mode, I'm not going to talk about it in any depth, is to do things such as have redundant cloud servers in boxes the size of Hayes modems, for people who remember that technology, bolted to multiple telephone poles and power poles in the neighborhood. So if somebody actually, a little boy with a squirrel gun shoots one of the data centers, it's a hot failover, hot spare, because this has to be redundant and reliable because it's our power system. And that's where the whole market occurs. That's where the AIs live. And the only thing that notion does is then it trades at the next level. So all the personal individual data never goes out of that microgrid, however defined, in the model I'm building on. It's not the only model there. Portland Power, whatever the name of the Portland Power Company is looking at putting transactive energy. They're very focused on their duty to serve, which is they must provide power in a reliable, non-discriminatory way. And so they're putting transactive energy, looking at putting transactive energy only on the water heaters and a few other key high energy devices that people can negotiate away, and then leaving everything else on a traditional model. That doesn't make sense to me, but it's a big world and people have different ways to choose things, so I'm okay with it. But my model, the Fractal Microgrid model, says the data never leaves, and the data center is internal to each microgrid, and it never leaves, it never goes to the wider world. Now, you thought of an interesting issue, and there are all kinds of regulatory and other issues. So should police be made aware of certain collective behaviors of microgrids if those microgrids agree to it? That's a very interesting question. It's outside the scope of transactive energy standards per se, but it's a very intriguing question, one I haven't heard before. And some neighborhoods would like to do that, and some neighborhoods would not. It's an interesting question. So I'm looking at these dappers, which can build whole clouds and a little box this big of a Raspberry Pi cluster. You can use the big data, big cloud operations to install other modules. You can have AI modules installed within a microgrid to watch it, to learn it at each level, and there could be different Dapper hosted AI bots from different providers giving information to the local market, whether it's as a buyer or as the market operator. There's a lot of room for diversity in this model of small, tiny containers, each fully containerized, each deployable, each a different security realm. I've worked with Dockers for years, and in the IoT spaces for buildings, there's always this concern that nobody is sure if we're using that library or not, so we better not delete it because there's too many programs in the one Docker. When you get into the Dappers, it's the one program, one library model. And some of those are languages like Python and Golang, which are great for AI, pre-customized for it, but can be deployed alongside in the clouds, managed by Kubernetes style management, but entirely independent, entirely living within the microgrid cloud. So that's one kind set of answers to, it doesn't answer your very good question, but it says that you have the tools to develop answers for it. Is that fair?
Toby,
Yes,
I'm
thank
an engineer, and so this is something that I do in and out every day. the containerization, and how we have the edge IoT. So we have artificial intelligence and we have IoT. It comes together to AIoT. And you mentioned about how we keep the data in the Dapper and not transfer the data to the upper cloud, and hence do the computation, do the artificial intelligence there on the edge itself. So I was just coming to the point that if you can do this, if you can bring the AI to the edge and do it, the privacy considerations will be minimized.
Yes.
And also, there is there any possibility of transparency that comes here? So when the energy company does this, so when they do it, are the people, can they ask questions on what is it that they are doing? Is it transparent to the people?
Well, in my model, and there are other models out there, and a lot of people have different views, is that because it's entirely fractal, my own internal house has the same features that the next level market has. So I can query how my house is using energy and the strategies it's using and it's doing with AI for my house. And if I want to get a customized AI that does something and put it in a container, because remember, Dapper isn't designed to be one thing sitting there. Dapper's fundamentally for a cloud. So if I could add an AI from a third party that has some special feature into my local cloud infrastructure, then I can ask questions about what I'm doing. Now, the next level, who managed this cul-de-sac? Who has the rights to ask questions? Is somebody allowed to ask questions about who was the biggest pig in the cul-de-sac? That's an agreement at that level. It's not going to be a one-size-fits-all agreement. If it's a campus or a military base, they all share common ownership, and you can ask levels at questions each level of the grid. As we go out into our neighborhoods, we're going to have different security decisions at different levels of deployment. But the AI containers can, in principle, be installed at each and every layer, including the leaves of the tree. And to answer questions, did that get to what you're reaching for?
Yes, thanks, Toby, for that. And I think you were presenting the next slide where you were talking about IoT, and we are really curious to learn about that. And we have roughly around 5 minutes.
Okay,
so,
I'll go back and share that one slide again, where what I was doing was talking about different places where I imagine AI at the edge. You might imagine different ones. This is not meant to be a comprehensive list. This is just where might it fit. So one, of course, is looking at the market. That informs bidding strategies, that informs predictions about what weather is going to cost tomorrow, what it's going to cost tomorrow, what it's going to cost in an hour. If I have a half an hour of power use, I'm looking at, is it better to buy an hour and try to sell 5-minute chunks back to other people, knowing that there's a risk I might not be able to sell them? Or is it better to go just buy 5-minute chunks right off and never have the ownership of the hour I don't need? What if I can't buy that last 5-minute chunk I need for that half hour? I mean, those are all things that the AI could be learning. So the trading strategy stuff. Physical systems, you have to predict what they're going to do. What are they going to do if they all try to run at the same time? One of the classic problems of some certain early transactive energy models is if the price jumps from $2 to $1 at 6 o'clock, everything every air conditioning system, every refrigerator, everything else turns on, slam bang at 1 o'clock. How do you deal with that? How do you blur the edges so you don't burn out the distribution system at these big price junctions? Well, the local microgrid manager, which to my mind is, again, a little AI thing, might sell the hours, then buy back the first minute, a limited number of the first minutes of the hour to smooth the boundaries, because it's seeing the overall market effects. So there's behaviors around there on the edge that AI could have a great place into, so that the electrical equipment's not shocked quickly. Then there's weather. So you can get a weather service. I have a phone in front of me, one of these surveillance devices that has the Weather Channel news on it, and I happen to know it's an IBM company, and I know that IBM sells weather feeds that are tuned by zip code and maybe finer than zip code. But if you're getting that feed to your house or to your office, you might know that whenever the weather's coming from the west, you always see 2 degrees cooler than they tell you. Well, can the AI learn that? Can the AI inform the house occasionally accordingly? Can the AI watch what the heating system does and the weather patterns that as it's being informed and come up with better energy purchasing decisions? I think they can, because that's exactly the kind of thing that AI can optimize in ways that are really hard for somebody to optimize centrally. And there's also understanding your operators. A human is interacting inside the house. If I'm looking at a house, an office could be the same. Is there a place for, if I say turn on the air conditioning at 8 in the morning because that's when I'm having a meeting, the air conditioning is going to be running full blast during the entire meeting, making noise, and it won't actually be the temperature I want till 8:45. Can the AI learn what the system will actually do and give me the results I want rather than the results I asked for? That's a place. So understand the relationship between each nanogrid and its operator. So I think there's a lot of places where AI is going to be very important and growing importance in this model. But it's hard for me to catalog all of them because we haven't done it yet.
So Toby, this is really good learning as students of AI, AV, and IoT, how we can marry these concepts together. And you talked about really tangible, real world stuff where AI can make a difference, where IoT can be improvised and put to use. So this was great learning for all of us. And we would like to thank you for this wonderful session. I'm sure each of the students who came here, they will have something to take away from here and apply to their research, apply to the working that they are doing, and it will surely be a memorable session for all of us.
Well, thank you. I just think of one last use case I'd like to leave you all with. There's a report of at least someone up in one of the towns that was turned off in Northern California, in the California mountains. They said, this is going to be no problem. I've got a solar panel on the roof. I've got an iPad. I've got a pool. I'll just catch up in my reading for the week without power. It'll be great. Well, the current model says your solar panel turns off if it can't see the grid.
Mm-hmm.
So that's rather than an anti-fragile pattern, that's an anti-fragile pattern. It breaks everything all the time, always. It's more than fragile, it's extra fragile. This is the only way you get to resilience. And it's learning, and it's not waiting for central control, and I think that's what we all want for the future, because we're going to get more intermittent, we're going to get thinner margins, and this is like one of the most important problems for all of us to solve.
Yes, something that's emerging. I don't know the word. It's more emerging than emerging tech is what I want to say. And thank you for this. And thanks a lot for this wonderful session.
I'd also like to draw attention to the last thing on the last slides. I know we ran out through it. And let me focus on the last one.
Okay.
I've had over a number of years conversations with some of the forward-looking facilities people inside NASA talking about the transactive energy type solution applying to all the other scarce resources that are in a space station. As components dock and leave, each can take their assets with them. As a micrometeorite takes out breathable gas, as other things, they see potentially this style and this approach as being essential to entering into the wider universe. So, but we have to start here on things we know, which is things like power.
Yes, Toby. So there was key learnings from the session that we all have taken, and it has really enriched us. And there's a big thank you on behalf of all the students here. And thank you, Toby. Thank you for this wonderful session.
You're quite welcome. I hope It was worth it for everyone.
Thank you so much. So next week we have Craig Pritzky, who's going to be talking to us about space and space technologies. So this will be a good direction to go into the emerging market, emerging technologies that you've set the stage for us. Thank you so much.
Thanks.
Thank you everybody for joining. WeeklyWed happens every Wednesday at 9 a.m. Pacific time. And we have a super session that's coming up next Wednesday. Please do not miss that. We will catch you next Wednesday.